Find the numbers greater than 23,000 that can be formed from the digits 1, 2, 3, 5, 6 without repeating any digit. So first let's decide if this problem is related to permutation or combination. So they said without repeating any digits, and we are dealing with our numbers, the number system we usually use. So this is a problem of permutation. So remember, and without repetition, so just remember no repetition, and the problem is related to permutation. So just remember this formula. So now the condition is that we can of course make a lot of numbers from these digits even without repeating any digit. But now the condition is we have to find those numbers which are greater than 23,000. So let's see what can we do about that. So let me divide the number into two sections. Okay, so first I have to make sure that the number I get here, because the number we need to find should be greater than 23,000. So it means I have to get a number greater than this number 23. Actually this is 23,000, but you can consider it even 23, it's fine. So it means I should always get a number greater than 23 or 23,000, whatever you think it is. So to get a greater number than 23, let me check the numbers. The given numbers are 1, 2, 3, 5 and 6. So if I get any number from these 4 digits 2, 3, 5, 6, whatever permutation I make with them of 2-digit number, it will always be greater than 23 or equal to 23 at most. Other than that, it will become 2, 5, 2, 6, and of course 2, 3. Then next I can reverse them, 5, 2, 6, 2, 3, 2. So you see, so these number always make a number equal or greater than 23, the position here, because I don't care about rest of the permutation. So whatever they make in this place after 23, it will remain equal or greater than 23. In fact, greater than 23, because we don't have any 0 and we can't repeat any digit. So once I get any of here at this location, I don't care what permutations the other numbers make here, because it will always be greater than 23,000. So let's see, and now the problem is this 1, because if this 1 comes at the first position, for example 1, 2, if I include 1 in the group, so it is 1, 2 and it is less than 23, because I know whatever comes after that, it is less than 23,000. So I don't know whatever permutation comes in this location. So the important thing is to see the number here, the 2-digit number here, if I divide the whole number into 2 sections. Second, if one makes a permutation with 3, 1, 3, 1, 5 and 1, 6, you see, so 1 cannot come at this location, because whatever comes after that, it will never be greater than 23 or 23,000, because the place is at that location. So it means I should make sure that 1 will never come at the first position, because otherwise this number is not greater than 23 or 23,000, because whatever comes after that, it doesn't matter, it will still be less than 23. So I don't care about these numbers, because I can calculate these permutations later. But first I have to make sure how many permutations I can make at this location, the 2-digit number, the section I have divided, that this, how many permutations I can make which are greater than 23, because after that these permutations are easy. I can calculate with just one formula. I already have NPR and it's fine. But first let me decide here. So 1 should not come at the first location. That is the first point. So can I put 1 at the second place? I mean, in this section, can I put it at the second place? Let's see. So if I want to, if I decide to put it at the second place, so I can put it like 2, 1. No, it is still less than 23. So it should not come at the second place, at least for this permutation. Let's see if it makes with 3, 1, 5, 1 and 6, 1. Okay, so it should not come at the second position only for 2, because it is 21,000 eventually, and it is less than 23, the condition given to us. But for the others, it's okay if it comes at the second place. You see, it's 31,000, 51,000, 61,000. Okay, so I think I have to do some work manually, and then I can do rest of the things using the formula. So let's calculate how many permutations can I make if 2 only for these 3 cases, because this should not be included, because 21 is less than 23. So okay, so if I make 3, 1, 5, 1 and 6, 1. Okay, now I make how many permutations I can make from rest of the numbers. So if I have 3, 1, then rest of the numbers are 2, 5 and 6 left, which can make permutations in this location. Similarly, if I have 5, 1, then I have the number 2, 3 and 6. Similarly, if I have 6, 1, then it is 2, 3, 5, 2, 3, 5. Okay, so now I need to calculate how many permutations are possible for these numbers, because this is of course constant for one case, and then I will multiply these 3 permutations with permutations made with these numbers. Of course they will change. For example, it is 2, 5, 6, then the next time it can be 5, 2, 6, 6, 2, 5. So a lot of combinations can be made, and this, then I will remove this sign here and it will become different numbers, right? So if I use my formula, that's just my formula NPR, these are 3 digits, and I want to know how many permutations I can make with 3 digits. So 3, it is P, 3 and 3, and this is actually true for all of them. P, 3, 3, 3 and 3. So it should be the same for all of them, because we have 3 digits and size of the permutation is 3, because we want to know how many permutations are possible, and then this person with 3, 1 every time. So 3, and I am using my calculator. P3, it says 6. So 6 permutations are possible with each of them. So we have 3 permutations in this section, 31, 51 and 61, and then for each of them we can make 6 more permutations in this section, the second one. So it means for these cases we will have total 18 permutations are possible when we place 1 at second position, because we can put 1 at the second place from the left side, only in 3 cases, and for each of these 3 cases we will have 6 more permutations possible in front of them, the 3 more digits left. So we can have total 18 permutations. Okay, so now the next. Now I don't care if 1 is not at the first position. I have excluded those things, and 1 can be at the second position from the left for any number, only in 3 cases, and I have calculated that 18 permutations are possible for those cases. So now we have calculated all the permutations if 1 is at second place and 1 is excluded. So now we need to calculate number of permutations, for example. So just remember this 18. So the number given to us 1, 2, 3, 5, 6. Let me check again. 1, 2, 3, 5, 6. Okay. So now I want to know 2, 3, 5, and 6. I want to know that how many permutations I can make from these numbers, and size of the permutation is 2. And then I will have rest of the numbers on this side, because you know I have splitted the actual number into 2 sections. I will have 2 numbers on left side because I want to know if this number is greater than or equal to 23. And then I will put rest of the permutations on this side, and then I can calculate the total number of permutations for each case. And I want to know how many permutations I can make from these numbers. You know, now there is no 1. You know why? Because I have calculated the number of permutations for 1 at the second location, and because I know those numbers are greater than 23, and now 1 is gone. So now I want to calculate rest of the permutations for 2, 3, 5, and 6, because I know whatever permutation I get from these numbers, it will always be greater or equal to 23, and that is perfectly fine. So first, this section is divided into 2. First I want to calculate how many permutations I can make from these numbers, right? This is simple question, because total number of digits 1, 2, 3, and 4. Okay, 1, 2, 3, and 4. So 4 P, and size of the permutation is 2, because in this area I want to know the permutation, the size of the permutation is 2. So it's 2. I want to know how many permutations of size 2 I can make from these 4 digits. So I am calculating 4 P2, and it tells me I can make 12 permutations of size 2 I can make from these 4 digits. Okay, and you know that for rest, whenever I will get a permutation here of 2 digits, rest of the number left to me are 3, right? Because if I get 2 numbers here and here, the total number of digits given 1, 2, 3, 4, and 5. So if I get 2 numbers on left side, this section, so I will have 3 numbers, the 3 digits on the right side. And we already know that if we are given 3 digits and I want to know how many permutations I can make, it's 3p3. And let me see how many permutations I can make. 3p3, and it's 6. Okay, so I can make total 12 permutations for of size 2 on this side, and for each permutation, I will have 6 permutations on the right side. So the total number of permutations should be equal to 12 into 6. And let me see what is the number. 12 multiplied by 6 and answer is 72. Okay, so now I have calculated the permutations if one is at second place from the left side, and I know that these permutations are 18. Now I have calculated all the other permutations where of course the left side is greater or equal to 23 is 72. So I will add 72 plus 18 to get the total number of permutations, and my calculator tells me that it's 90. So you can make 90 permutations, and the number and those permutations will represent numbers greater than 23,000. This question is a bit complicated, and I hope you will understand if you watch it several times. And still, if you are still confused, let me do some extra work manually. If you have understood the question, you can just stop here. If you want to understand into the depth, I can do some manual work for you. So you know that I calculated number of permutations when one is at second place from the left side. Okay. So now next, what am I doing here? Because I believe this part must be confusing to you, that why I am calculating the number of permutation on the left side from these digits. So let me explain it or reiterate once more. So I chose the numbers 2, 3, 5 and 6 because now I want to calculate how many permutations I can make, and size of the permutation should be 2, because on the left side, this side will decide if the number is greater than 23 or not. And I know that all the permutations of size 2, all the permutations made from these digits will be equal or greater than 23. So I calculated all of them. I chose 2p2, and I can write these 12 permutations for you, for example. So the numbers 2, 3, 5 and 6, and our formula told us that I can make 12 permutations from these 4 numbers. So these numbers should be 2, 3, 2, 5 and then 2, 6. Then the next should be 3, 2 and then 3, 5, because I can't repeat any digit, and then 3, 6. Okay, so what could be the next? 5, 2, 5, 3 and then 5, 6. Okay, and then 6, 2, 6, 3 and 6, 5. So let's see how many permutations I have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You see? So I got 12 permutations. These are all the permutations possible from these digits. I am not putting 1 because I have done that work separately. You see, for these 2 digits, you see, I have already done that because I checked if 1 can be at the first position, and I saw that no number will be greater than 23,000 if I put 1 on the first place from the left side. Then I checked if 1 can be at the second place, and I checked that only for the permutation 2, 1 it will be less than 23. For rest of the permutations it will be greater than 23,000. So I put those 3 permutations here, and I calculated the rest of the permutations on the left side. For example, if I have 3, 1 here, so I put rest of the numbers here, and I calculated the number of permutations possible in this area. That was 6. Similarly, for this permutations 51, I got 3 more permutations because the rest of the numbers are 3 on the right side, and I can make 6 permutations. Similarly, for the third case where 1 can be at the second place from the left side 6. So I have calculated those things. Now I am left with the numbers 2, 3, 5 and 6, and I know all the permutations of size 2 are greater than 23. So I use the formula 4p2 and I know that I can make 12 permutations, and I did that work in front of you, that these are those 12 permutations, and you see all of them are greater than or equal to 23. So I calculated those permutations on the left side. Now I will go to the right side, because after putting 2 numbers on the left side, I will have 3 numbers on the right side, and it doesn't matter what are those numbers, because of course these numbers will be different for each permutations, but the number of permutations possible with 3 digits is always 6, because value doesn't matter. So I calculated for each side, right side, the 3, I will get 6. So total I will have 12 permutations on the left side, and for each permutation I can make 6 more permutations on the right side. So I multiplied 12 into 6, I got 90 permutations for 2, 3, 5, 6 and 18 for the 1. So I will add all the permutations and the answer is 90. I hope you will understand it now. If not, play it again and try to understand. If not, try to solve this question yourself, that what is actually going on.